All right, here we go. Let's get this review done. First thing, static equilibrium is a condition where where there are no net external forces acting upon a particle or rigid body, and the body remains at rest or continues at a constant velocity. Scalar quantity has magnitude only, and a vector has both magnitude and direction. All right, keep in mind for these, where you need to find the centroid, you have to add in the x and y axis so you know where we're referencing from. And we're dividing by 2 on a rectangle. So in the x, it would be 2 inches. Don't forget your units. In the y, it would be 4 inches. Don't forget your units. On the triangle, we'll go from these reference axes. Here's my x, here's my y, and we divide by 3. So it'd be 3.3 repeating inches, and 8 divided by 3 would be 2.6 repeating inches. For a complex centroid, you'll notice it's the same 2 shapes that I gave you up top here, trying to make it a little bit easier for you. You do need to find the area of 1 and 2, so we divide it into simple shapes, and we've got our areas there. And the formula is the sum of the xa's divided by the sum of the a's for x bar, and for y bar it's the sum of the ya's divided by the sum of the a's. So this little table is meant just to help you with that. So the x centroid of 1 is 2 inches, and 2 times 32 is 64 inches to the 3rd power. And for the second one, it was half the base, which is 5. 5 times 4 is 40. And the x bar for it is 3.3, but you've got to add that 4 inches. So 4 plus 3.3 repeating is 7.3 repeating. And 7.3 times 40 gives us 293.3 repeating inches to the 3rd power. It says to do the sum of them. That's what this S is actually supposed to be, a sigma. I think it got converted wrong. It was supposed to be a sigma for sum. So the sum of the areas is 72, and the sum of these, so let's add 64 to that, is 357.3 repeating. So this becomes 3 by 72, which gives me an x bar of 4.963 inches. Inches to the 3rd, inches squared, those cancel and leaves just 1 inch. Alright, do the exact same thing for the y bar. So in the y, this one's 4. 4 times 32 is 128 inches to the 3rd. And 8 divided by 3 is 2.6 repeating. 2.6666 times 40 is 106.6 repeating. And we'll go ahead and add 128 to that, which gives us 234.6 repeating, and we'll divide that by 72. So 234.6 repeating divided by 72, inches to the 3rd, inches squared, and that gives us 3.259 inches. All right. Hope you guys can see all that. Next thing, let's go ahead and switch it up to a blue color, just because we're done with centroids now, and I need a little change here. So the cross-sectional area, it tells us that the base and the height are 2 inches by 5 inches. So the cross-sectional area is the base times the height, so 2 times 5, which is 10 inches squared. The moment of inertia, I, is base times height to the third divided by 12. So 2 times 5 to the third divided by 12. 5 times 5 is 25, times 5 is 125. So that becomes 2 times 125 divided by 12. So it becomes 250 divided by 12. And 250 divided by 12 is 20.83 repeating inches. And let's see, that was inches, 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 inches to the fourth power. All right. Beam deflection is delta max. And that's equal to F, the force, times the length in inches to the third power, divided by 48 times the E times the I. So it told us the force was 10 pounds, so it'd be 10 times the length is 60 inches, 60 to the third, divided by 48 times E, which is 1,800,000. PSI times the I, which we just solved for, 20.83 repeating. All right, so I'm going to just do that in my calculator. 60 to the third is 260, which makes it 2,160,000. And we'll divide that by 48 times 1,800,000. 1, 2, 3, 4, 5, 6. Good. Times 20.83333333. Biggest mistake people make here, guys, is that they actually, oh wow, 1800. How many zeros is that? 1, 2, 3, 4, 5, 6, 7, 8 zeros. 2, 3, 4, 5, 6, 7, 8 zeros. They actually miss a decimal place or something. So double check the math that you do on this to make sure that you put it in correctly. So 2160000, or they'll forget a zero. That's pretty common as well. Divided by the answer. And we got a beam deflection of 0.0012 inches. 0.0012 inches. All right. So that's page 1. Let's go ahead and jump over to page 2. All right. Sorry, guys. So here it says to just go ahead and draw in, label, and calculate the reaction forces. So when it says to draw in, it's very important for your free body diagrams that you include the reaction forces for these supports. So the reaction force at B in the Y, the reaction force at A in the Y, and the reaction force at A in the X direction. And it would be nice to go ahead and add in some, since we have to calculate reaction forces, some directions. So we choose our pivot always as the pin support. This one's pointing directly at it, so it would not be a moment. No moment. And with this one, it would cause rotation in this direction, which is counterclockwise and therefore positive. So we know this one has to go the opposite direction, go clockwise and be negative. For it to do that, this reaction force has to be pushing down. If that force is pushing down and that one's pushing down, we don't know what this one's doing until we figure out how much that is. This one's pushing to the left, So we know this reaction force has to push to the right. All right. So let's go ahead and do the calculations, and the way we do that is the sum of the moments has to be 0, and we do the moments around the pin support A. And our moments are, this 70 is a 0 moment, so 80 times, what is the perpendicular distance? 10 feet. And we'll actually say not plus, but minus the reaction force at B and the Y times, it is 20 feet away perpendicularly, equals 0. And solving the math, 800 divided by 20 is 40 for our reaction force at B in the Y direction, pounds of force. 40 pounds of force. All we did was we added this to the other side, so it was 800 equals RFBY times 20, and then divided both sides by 20. And that's how we arrived at 40. Next, we have to do the sum of the forces in the X have to be 0. My X forces. Now we're done with moments, and a lot of people confuse it and think we're still looking at moments. Now we're just looking at arrows. And specifically for the X, it's the arrows going this way and the arrows going this way. And together they should be equal to 0, or the ones going to the right should equal the ones going to the left. I have 80 going to the left. That means that RFAX has to go to the right because it's the only other horizontal force, and it has to be 80. So RFAX, 80 pounds force. And the last one we have to look at is the sum of the forces in the Y have to be 0. And my Y forces, I've got 70 coming down, so the downs have to be equal to the ups. I got 70 pushing down, I got 40 pushing down, and so together that equals RFAY, because you notice I got RFBY going down and I got 70 going down, so this one definitely is going to go up to counter those two, and it has to be 110 pounds of force. So RFAY equals 110 pounds force. All right. The dog and the cat. All right, here we go. Fighting over a bone. We're both pulling on a bone. Let's see which way the bone goes. So for this one, what you have to do is figure out the components of those two vectors, the vector representing the dog's force and the vector representing the cat's force, and then you have to add them together, right? But keep in mind, because the dog is pulling to the left, we're going to count this X as a negative. So it's like this and like this for its components, and this one's components are like this and like this. So the cat will go with C and the dog will go with D. And so we've got D in the X, and we've got C in the X, we've got C in the Y, and we've got D in the Y. Now they're both going in the Y direction, so we can add their Y's together. The sum of the Y's is going to be D in the Y plus C in the Y. The sum of the X's is going to actually be C in the X minus D in the X, right? Depending on who's pulling harder, it's going to be going to the left or going to the right. And it looks like 15 newtons is more than 10 newtons. They're at the same angle, so it's going to be going to the left. So this will be negative just to tell us the direction in that case. So let's go ahead and do the math. This is, of course, 35 degrees. So I would use sine and cosine. Sine will give me the Y, cosine will give you the X. And ask your mom for some juice, buddy. Sorry. Can you shut the fridge, though? Good Lord. So 10 times the sine of 35 will give me C in the Y, and 10 times the cosine of 35 will give me C in the X. The sine of 35 will give me D in the Y, and 15 times the cosine of 35 will give me d in the x. All right, so let's make sure our calculator's mode is in degrees, because we're using degrees for our angles. And what we're going to do is put in 15 times the sine of 35, which is 8.6. So 8.603, and that is newtons for d in the y. And 15 cosine 35 gave me 12.287 newtons for d in the x. And 10 cosine 35 gives me 8.192 and 8.192, and 10 times the sine of 35 gives me 5.736 newtons. All right, adding them together in the x direction, let's see, we had 5.736 minus in the d in the x was 12 point, that's actually a y, isn't it? So 8.192 minus 12.287. So 8.192 minus 12.287, and that gave me a negative 4.095 newtons. And adding the y's together, 8.603 plus 5.736, and that gives me 8.603 plus 5.736, 14.339. Okay, so what do these mean? It means that it's going up for my sense and it's going left. All right, its direction we don't know because we have to do some math for that, and its magnitude we don't know. To figure out the magnitude, we're going to do Pythagorean theorem. So the square root of 4.095 squared plus 14.339, and would you mind taking them out of here, please? Thanks. Plus 14.339 squared. I think everybody's losing it a little from being in the house for so long. So the magnitude is 14.912 newtons. All right. All I did was let me see if I can draw this somewhere. Basically, we came up with our x and y components. And so we know it's going in this direction because it's going back in the x and up in the y. And this is 4.095, and this is 14.339. So if I wanted to find the angle measurement, I would use tangent inverse of opposite 339 divided by 4.095, and that gives me 74. So it's going up quite a bit, but 74.061 degrees. All right, so its direction would be 74.061 degrees, and that would be, let's say, clockwise from the negative x-axis. All right, there you go. The next one, let's pause for a sec, actually. All right, so the moment here, they want us to do the moment around A. I think it said that, force at point A. Determine the moment from the force at point A. Okay, so the moment is actually going to be around our pin support, which is this one down here. Sorry, you can't see that. Slide that up a little bit. A little more. All right. And so here's my pin support. Here's A. And if I were to push on this, it would actually not cause any rotation. So it's a zero moment. It's none. It has no moment whatsoever. Over here, from A is right here. Here's my pin support. So this would actually cause rotation this direction, which is counterclockwise. So it is a positive moment. And the force is 40. So moment is a force times its perpendicular distance. Now, they didn't give us units, although this is in feet, I'm sorry, so it must be in pounds, times, it's probably my mistake, the perpendicular distance to that, which is 4 feet. And 4 times 4 is 160 pound feet moment. And it is positive because it is going counterclockwise. All right. Last page. Our favorite. First thing is it statically determinate? And statically determinate is where we say 2 times the number of joints is equal to the number of members plus the number of reaction forces. So A, B, C, D, and E, those are joints, so it'd be 2 times 5. Is that equal to the number of members? AB is a member, BE is a member, AE is a member, AC, AD, DC, CE. So how many is that? 1, 2, 3, 4, 5, 6, 7. Plus the number of reaction forces. And you'll recall you've got 2 at the pin and 1 at the roller. 1, 2, 3. So is 2 times 5, which is 10, equal to 7 plus 3, which is 10? Yes, it is statically determinate. Now we're just repeating how do we figure out the reaction forces. So label them: reaction force at B in the X, reaction force at E in the X, reaction force at E in the Y. And very quickly, some of moments. So I've got this one and this one, both of which are going counterclockwise. So they're positive moments. And that means that RFBX is going to have to go clockwise and be a negative moment. All right. So in the interest of time, I'm just going to say 75 times 3 and 40 times 2 minus RFBX times 3 equals 0. 75 times 3 is 225, plus 80 is 305. 305 equals RFBX times 3. So divide that by 3, and what do you get? 101.6, I believe, right? Let's just make sure. 101.6 repeating pounds force is RFBX. 101.6. Now some of the forces in the X direction. We got 75 to the left. We got RFBX to the right. So 75 going, let's do a different color. So 75 minus 75 plus 101.6. So that means it's going to be minus. So I know that RFEX equals 0. So what's the difference is 25, 26.6. So RFEX is 26.6. Repeating. 26.6 repeating pounds of force. And finally, some of the forces in the X, that was the X direction. Sorry. So, yeah, in the X. Now in the Y, let's go ahead and move this over here. And what do we have? We have 40 going down. So minus 40 plus RFEY y equals 0, so RFE y is 40, and it has to go up. All right, easy peasy, right? So that's the reaction forces. I can write them down at the bottom here. RFEX was BX was 101.6 repeating pounds of force. EX was 26.6 repeating pounds of force, and EY is 40 pounds of force. Now to do the member forces, we've got to draw our free body diagram. So I'll go ahead and start at A, and we've got 75 pushing this way. We've got member AB, we've got member AE, and we've got member AC, and we've got member AD. There's a lot going on there. I'm not going to go anywhere near that one, at least not right away. At B, I have my reaction force, which is 101.6 repeating pounds of force. And I've got member, what is that, BE? Okay, not so bad. And I've got member AB, not so bad. I'll probably start here, but let's go down here to E. E has member BE, E has member AB, and E has member CE. It also has, what do we say, 40 going up, and it has RFEX going to the left, and that's 26.6 repeating pounds of force. All right, I've actually kind of run out of colors here, so let's do C. And at C, we've got member AC, we've got member CE, and we've got member CD. And finally, what colors do I have? What color is this? I think that's black. Use one of my kids' pencils here. We've got coming down 40, we've got CD, and we've got AD. Now we need to figure out all those members, all 1, 2, 3, 4, 5, 6 members. So we always start at the easiest one, and in that case, it's going to be B. It only has 3 things, and we know one of them. We don't know any. This also only has 3. This also only has 3, and we know one of them. But this one has an angle, and this one doesn't. So we'll start here, and the sum of the forces in the X have to be 0. We've got AB plus 101.6 repeating equals 0. So AB has to go to the left. So we'd say actually minus AB plus 101.6, and AB is 101.6 repeating. All right, and if it's drawn away from the joint, it's always drawn away from the joint. So over here, I know it's 101.6 repeating and away from the joint. Some of the forces in the Y, and this is all at B, have to be 0. And so BE is the only Y force, so it is 0. So it's always 0. All right, that's good stuff. So I can bring that down here as well. I actually know 3 forces here and only have 2 unknowns. So let's go there next, and that's red. So what do we got? Some of the forces in the X have to be 0. We've got CE, we don't know. We've got minus 26.6 repeating. We've got AB in the X, we don't know. 1, 2, 3 X forces. Somehow those all end up being 0, but we don't know if this is positive or negative. We don't know if this is positive or negative. So we're just going to pause there. Let's go down here to the sum of the forces in the Y have to be 0. We've got 40 going up, so it's positive. BE is 0. So then that's actually going to be equal to AB in the Y direction, because that's my only other force. which means AB and the Y has to go down, which means AB and the X is going to the right. So it's positive. So we still don't know which way CE goes because we have to figure out what AB and the X is. And the way we do that is we draw our AB in. So here's AB, and AB and the Y is 40. And AB and the X we don't know. And you can use SOHCAHTOA because we can figure out the angle measurement, but I think it's actually easier to use similar triangles. And look at AB over there. It's 1 foot and it's 3 feet. So similar triangle says 40 over 3 should be equal to AB and the X over 1. So 40 is equal to AB and the X times 3. Divide both sides by 3. And 40 divided by 3 gives us 13.3 repeating, which is our AB and the X. So now we know this is minus 26.6 repeating plus 13.3. So which one's bigger? The negative is bigger, so it's plus CE equals 0. So we know CE has to be 13.3 as well. 13.3. And we said it has to be positive, so it's going to the right. It's drawn towards it, so it'll be drawn towards the joint here as well. And that means it's in compression. When they're drawn away, like up here at AB, that means they're in tension. If it's 0, it's neither tension nor compression. All right. So back down here, we know this is 13.3. If we know AB and the Y, and we know AB and the X, we can use Pythagorean theorem, 40 squared plus 13.3 squared, to figure out what AB is. So square root 40 squared plus 13.3 squared, and that gives me 42.164 pounds of force. So now I know AB, I know BE. Oh, this is AE. Oops. AE. E and the Y. E and the X. That was a big mistake, guys. Sorry about that. I'm sure you all caught it, though, before me. So E and the X. E and the X. I don't know why I labeled that AB. So we know AE, we know AB, we know BE, we know CE. We don't know AC or CD or AD, so let's get those done. And the way we like to do that is we just go to the next easiest one. So that would be right here, and I think that's this pen. So we know CE is going to the left, and the sum of the forces at C in the X direction have to be 0. So we've got minus 13.3 repeating plus CD, so it has to go to the right, equals 0. So CD is 13.3 repeating. And if it's going to the right here or towards the joint, it's going the same here. It's in compression. And AC, sum of the forces at C and the Y have to be 0. So AC is 0. Alright, sorry about that. So we know we're over here. We know CD is in compression. So now we know CD, we know AC is 0. I forgot to write that down. So 0, 0 has neither compression nor tension. And we got to do our last one, which is to figure out AD. And the sum of the forces here have to be in the X have to be 0. So AD in the X is going to be equal to CD, or 13.3 repeating. AD in the Y, sum of the forces in the Y have to be 0. So AD in the Y has to be 40. Um, this is going down, this is going left, so AD has to go up and right. So it's in tension, and we can do the same to it over here. And let's see, if we know it's X and Y components, then we know AD is the square root of 40 squared plus 13.3 squared. Hey, that's familiar. That's the same as this one. So AD is 42.164 pounds of force. All right, that's that. That's your review, ladies and gentlemen. I guess we can write it down so that's easier for you guys to all check. What do we say? We said AC is 0. We said CD is 13.3 repeating pounds of force. We said AE is 42.164 pounds of force. We said AB was 101.6 repeating pounds of force. We said AD was 42.164 pounds of force. And we said CE was 13.3 pounds of force. All right, I think that's all of them. Thanks for watching, and have a good one.